All right, so let's have a look at some more of these questions that are in our level 10, 11, nonlinear relations. What are the solutions for this equation? I think we just finished looking at this equation, and we finished with x equals 0, x equals 1.5. Let's look at what are the solutions for this equation. Now, we're going to factorize when y equals 0. So 0 equals x squared minus 8x plus 15. Some of you will know that you can use the quadratic formula when it equals 0. So this will be negative b, so positive 8. B squared is 64. Minus 4 times 1 times 15, minus 60. So you get square root of 4 over 2 times 1. 8 plus and minus the square root of 4. So we get 10 over 2. And 6 over 2, which is 3. So we got 5 or 3. The other one was to factorize two numbers that multiply to give 1 and multiply to give 15 is 5 and 3. So you get 1x plus 5 and you get 1x plus 3. But it has to be a minus. So 1x minus 5 and 1x minus 3. That gives us still negative 5 times negative 3 is negative 15, but when they add it, it becomes negative 8. Therefore, if that equals 0, this bracket equals 0, or the second bracket equals 0. So from the first bracket, x has to be a 5. 5 minus 5 is 0, or 3 minus. So you get 5 or 3. So whether you use quadratic formula or whether you use factorizing, you should both get 5 and 3. Okay, I've got to keep going out and coming in because this is what happened during class and it doesn't seem to accept my answer for some reason. We might need to do this for every question. Okay, intermission is going from question to question. So we got 5 and 3 for this question 15. And that's that one there. And we go to question 16. And we want an equation where x equals 2 and x equals 5. Well, if x equals 2, then the bracket would be 2 x minus 2. And if the solution was x equals 5, then the bracket was x minus 5. This is working backwards, equals 0. And then you expand that, you get x squared minus 5x minus 2x plus 10 equals 0. X squared minus 7x plus 10 equals 0. And we want the quadratic formula, so y equals x squared minus 7x plus 10. By the way, also this graph crosses the x-axis at 2 and 5. And it's going to come across at 2 and 5. It's a very bad quadratic equation. It'll cross at 10 up here. So, oh, we didn't have to expand it. We could have just looked at the bracket. Oh, no, we do have to expand it. It's the last one. All right, so the last one. And I've got to go out, come back in, and select the last one. I don't know why it does this to me. Oh, well, sorry about this. The last one. What is the degree of this polynomial? The degree is that that highest power of x is a third degree polynomial. So you look at the largest power of x, so it's a 3. It's a third degree polynomial called a cubic. What is the value of the polynomial of 4? We have to substitute 4 into that equation. So where x is, we've got to change x for 4. Minus 5 times 4, minus 15. So you get 64, 16, 20, minus 15. That's 15 up there. 70, 80 minus 35 equals 45. So we've got polynomial 4 is 45. Polynomial 4 is 45. What's it doing? Logging in again. This is why I have to record it, because it was playing up during class. I didn't think to turn it off and on. And that was question 17. Or is it 18? 18. And we wanted to select 45. 19. Okay, what is the quotient and the remainder? All right. A few ways you could do this. I'm going to do it the long division way. Divide by x minus 3. So we want x times something to be x cubed. X cubed. And that's going to be x times x squared, x times x squared. So we multiply x squared times x minus 3. That gives us x cubed minus 3x squared. We then have to subtract that from above. So that becomes 0x cubed, becomes minus negative 3x becomes plus 3x squared. All right. Now we do x times something to be equal to negative 5x squared, that first term there. And that is negative 5x. So we put a negative 5x here. We put a negative 5x in the box. Then you bring negative 5x over here and multiply it by x minus 3. That gives us negative 5x squared, which is what we wanted, plus 15x. And we subtract. So we subtract, that becomes plus, subtract, that becomes a minus. So we've got negative 18x. Bring the minus 7 down. And we want x times something to be negative 18x. So that is negative 18. We put a negative 18 in there, negative 18 in there, negative 18. We multiply by x minus 3. And that gives us negative 18x plus 54. And we subtract. So that gives us negative 61. Remainder negative 61. So this is our quotient, and this is our remainder. And that's the last one. X squared minus 5x minus 18. Next question. We want to divide by x minus 1. So x times something to be x cubed. That's going to be x squared. And we multiply by x squared. So that becomes x cubed minus x squared. We subtract x cubed minus x cubed is 0. Negative 4x squared minus negative x squared is negative 3x squared. And bring that down. Now we want x times something to be negative 3x squared. And that's negative 3x. Negative 3x gives us negative 3x squared plus 3x. We subtract, it gives us 0. It gives us negative 18x. And bring the plus 18. So x times what to be negative 18? X, so it's negative 18. Negative 18. That gives negative 18x plus 18, and we get a remainder of 0. So it's perfect. The answer is x cubed. If we factorize x squared minus 3x minus 18, two numbers that multiply to give 18, and add to give negative 3, will be negative 6 and 3. So we want a positive 3 in there and a minus 6 in the second one. A 3 and a negative 6. What are the x-intercepts? So the x-intercept is that second step where we let y equal 0. So y equals 0, you could use the quadratic formula, or you could factorize. I'm going to factorize two numbers that multiply to give 1 and multiply to give 72. 1 times 1, 12 times 6, that won't work. 36 times 2, no, we want negative 17. 8 nines are 72. We want a negative 8 and a negative 9. So negative 8 times negative 9 equals 72. Negative 8 plus negative 9 equals negative 17. So if we factorize that, we get x minus 9, x minus 8. Therefore, we can see the solutions now. That will cross the x-axis at x equals 8, because 8 minus 8 is 0, and x equals 9, because 9 minus 9 equals 0. So it's the first one. X equals 8, x equals 9. One question at a time. The graph of this equation All right, a few things I really haven't given you much practice on. Okay, it's +1, so it's a happy graph. In fact, they're all happy graph. A is 1. It's going to cross the y-axis at 5. So that leaves, they're all, okay, that's all of them. They're both positive, okay, so it's going to turn on the left of the y-axis. So they're all turning on the left of the y-axis. Okay, they cross, it's going to cross how many times? Let's do the discriminant. Remember, b squared minus 4ac is 36 minus 20. Okay, 16. So it'll cross twice. So it's either 1, 3, or 4. So let's factorize this. Find the x-axis intercepts. It'll cross the x-axis at -5 or -1. That only leaves the fourth one, doesn't it? Okay. Sometimes you have to graph the whole thing before you can make your choice. Last one. 23, complete the graph. Well, it's crossing it. You see, it's crossing at -3. So the last number will be -3. Now it's crossing here at 3 and 1. So if I expand this, that would be x plus 3 from -3. And it's crossing at 1. So that would be x minus 1 becomes x squared minus x plus 3x minus 3. Okay, we've got our minus 3. So that would be plus 2x. So it's x squared plus 2x minus 3. Notice how you got both positive a is 1, b is positive 2, so it's turning on the left. It turns at negative b over 2a, which is -2 over 1. We could have worked it that way if we wanted to. Let's keep going. What type of graph will this equation give? All right, it's not linear, it's not a circle. Now, there's a mention of a cubic. A cubic has a cubed in it, like this. It doesn't have to have all the numbers, but a cubic will look like this. But the first one we've got is only it's got a squared So because it's got a squared, it's a quadratic. It's a quadratic graph. Not letting me answer it. Go out and come back in to answer it. Strange. Quadratic. X power of 7 is 128. Two ways we could do this. You know, you could say, well, 2 to the power of 7 is 128. Therefore, x equals 2. That's called by matching the same position, same numbers. Or you could take that 7 across and make it the 7th root of 128. So if you can get your calculator to get the 7th root of 128, that would give you 2. I hope I'm sharing. Yep. Really sad. Two more. And I wanted 2. And the next question. Oh, the log of now we haven't done many of these. The thing is, the log is an index. This is log notation. And this says that the base is 3. The log is the index. And the normal number is x. So we convert that into what they call index notation by rearranging the positions. And this says that 3 is the base. The log is the index, right? I'll just put here the log is equal to the index. That's just what the log is. It's the index. So the index is 4, and the normal number is x. So x is 81. And so there we go. X is 81. X is 81. Five x plus 9. We're going to use matching for this strategy. I'm going to change 16 into 4 squared, so I'm going to leave the 4 there. I'm going to change 16 into 4 squared. And that, you multiply that. And then we use what's called matching. And that means that if the bases are the same, the indexes are the same. Therefore, 5x plus 19, or 9, is going to equal 8x. And then you solve this normally. You take that 5x across to be 8x minus 5x, so it's 3x. Divide that by 3, and you get x equals 3. So you let these be equal to each other. Since 4 is 4, 5x plus 9 will equal 8x. X is 3. Okay, 2 decimal places. This is where we need our calculator. The base is 3. The index, or the log, is x. And the normal number is 21. So this is called index notation. I'm going to change that from index notation into log notation. Log notation is where you say that the log is equal to the index. So the log is equal to the index, the log equals x. So we get that from the middle line here. The base is 3. The number is 21. Okay, so on the calculator, you can either put that in on your calculator, or if you go the log of 21 divided by, I'll rewrite this differently. The log of 3, that is also a different way. If you just have a log 21 button, you can go log 21 divided by log 3 and get log 21 divided by log 3. By the way, it's not going to be log of 7. It is equal to 2.77. To 2 decimal places, 2.771. So to 2 decimal places, 2.77. So that's the first answer. By the way, you could have done this easier by going 3 squared is 9. 3 cubed is 27. So that has to be somewhere between 2 and 3. Because 3 squared is 9, too small. 3 cubed is 27, too big. So 2.71 is the quickest way you could do it. This is the quickest way, is up here. So it's 2.77. All right, so the x-intercepts is when y equals 0. And if it's already factorized, 0 equals x plus 2. That bracket has to be a 0. That bracket could be a 0. Or that bracket could be a 0. So x plus 2 equals 0. Or x minus 1 can equal 0. Or x plus 8 can equal 0. So from the first one, x would equal negative 2. Second one, x is positive 1. Third one, x equals negative 8. That's the first option. Negative 2, positive 1, negative 8. First option, negative 2, 1, and negative 8. Correct x-axis for this, well, this one is a little bit more difficult. This one you've got to find 3 numbers that multiply to equal, it's going to be an x. Right, what's one number? Well, one of the numbers, it has to multiply to equal 8. So the numbers on the end means you can either have a 1, a 2, a 4, or an 8 in those positions. So let's try, let's see if 1 makes it 0. 1 cubed plus 1 squared minus 10 times 1 plus 8. So 1 plus 1 minus 10 plus 8. Okay, 1 works. Therefore, we call this the factor theorem. If 1 works, you need a bracket which says x minus 1, because that would give us the value of 1. Now, if x minus 1 is one of the bracket, you have to factorize this by using our, I would say, rather than guessing and checking, so x times x squared is x cubed. So if I expand this, I get x cubed minus x squared. You then have to minus, so x cubed minus x cubed is 0. X squared minus negative x squared is 2x squared. Bring that down to be minus 10x. Now, x times what to be negative 2x, and that's minus 2x, would give us minus or positive? Positive. Because 2x would give us 2x squared minus 2x. And that would mean 2x squared minus 2x squared is gone. Negative 10x minus negative, that makes negative 8x. Bring that down. And we want x times negative 8 would equal x minus 1. So we get negative 8x plus 8. Okay, good. All we have to do is factorize x squared plus 2x plus minus 8. So 2 numbers that multiply to give negative 8 and add to give 2 are negative 4, positive 4 and negative 2. Positive 4 and negative 2 are the other 2 brackets. Positive 4 and negative 2 would equal x squared plus 2x. Therefore, we would get x equals 1, negative 4, and 2 is where it will cross the x-axis. 1, negative 4, and 2. That's the first option. The other option for that last question is this: you substitute each of those three numbers in, and it has to give you a 0. So that's an easy way of doing it, is just substitute each number. And if it gives you 0, then it's correct. 2 cubed plus 2 squared minus 10 times 2 plus 8 would be 8 for 12. 12 plus 8 is 20 minus 20. If you substitute -4 in, you should also get 0. So x-intercepts will make it 0. Now this is a little bit trickier. See how it crosses the x-axis at zooming in? Across the x-axis at -5, -2, and -1. -5, -2, and -1. And so there you go. Now if you expand this, you will get 5 2s of 10 plus 1. You'll get 10. See, it crosses the y-axis at 10. So let's expand. I'll expand first to x squared, 2x, 5x plus 10. And we still have x plus 1 on the end there. I'm just going to let that equal to 0. So let it equal to y now. So x squared plus 7x plus 10. When we expand that, we get x cubed plus x squared plus 7x squared and 7x plus 7x plus 10x plus 10. And that gives us x squared plus 8x cubed plus 8x squared plus 17x plus 10. And that's the second option. And that what is x squared plus 8x plus 17x is the second option. Notice how I use the x-intercepts to get the 3 brackets. And then you expand into the answer that they're looking for. If it crosses at 5, it's x minus 5. If it crosses at -5, the bracket will be x plus 5. And I think it was the second one. 32. All right, let's practice this skill again. This time we have to sketch it, all right? So we know the y-intercept will be the number on the end when x is 0. So the y-intercept will be -4. And that means it's either the third or the fourth graph, because they're the only two crossing at -4. Let's factorize this. Let's find numbers. Actually, let's look at our x-intercepts and make a choice. So the third graph crosses at -3, -1, and +1. -3, -1, and 1. The fourth graph cross at -4, -1, and 1. Okay, so the only difference between these two is, does the graph cross at -3 or -4? Because the other 2 points are the same. So if you substitute -3, you've got to get 0. Well, if it's -3, if you substitute -3, you've got to get a 0. So let's substitute -3 into the equation and see which one is, we're across the x-axis. -27, 4 9s 36, plus 3 minus 4 So we've got 39 and negative 31, not 0. All right, so maybe it's not the third one. Let's substitute negative 4 in, and let's just be sure. 4 times negative 4 squared minus negative 4 minus 4. So 4 cubed and 4 cubed is gone. This is negative 64. This is positive 64. This is plus 4, minus 4. Yeah, it's negative 4. So it's going to cross at negative 4. It has to be the last graph. See, we didn't even have to we didn't have to factorize. You could have factorized and worked out which graph, but we didn't bother this time. We used different strategies.